Gasoline port fuel injection is the most common drive system for passenger vehicles worldwide and will remain so beyond 2020. Bosch provides the system technology for gasoline port fuel injection on every continent on Earth. International presence means that Bosch knows the special requirements of the markets and is able to respond to specific needs locally and globally. The system offers an optimal balance of economy and performance, especially for gasoline engines with a specific performance of about 60 kilowatts per liter and downsizing concepts of up to 25%. Bosch designs and manufactures a wide range of powertrain technologies for vehicles with gasoline port fuel injection. The Bosch range includes individual components as well as complete synchronized systems. For the fuel supply, Bosch offers the fuel supply module with an electrical fuel pump and a medium pressure sensor. These components provide the required amount of fuel under specific pressure levels from the tank all the way to the fuel injectors. The fuel is transported by the electrical fuel pump, compressed to injection pressure, and then stored in the fuel rail. The fuel rail supplies the fuel injectors under steady pressure with fuel. The fuel injectors are responsible for injecting the fuel into the intake manifold, so that together with the intake air, a homogeneous air-fuel mixture is formed. The electromagnetic fuel injectors, which determine the start and duration of the injection, have ultra-precisely manufactured spray holes that ensure fine fuel atomization. A key element of gasoline port fuel injection is air intake control. In this process, various input variables are metered to achieve optimal combustion. These input variables include the amount of air taken in, which is measured by the hot film mass airflow sensor. Further along in the intake manifold, the low pressure sensor measures the air pressure. The measured air pressure and the engine speed are used to calculate the air mass that has entered the engine cylinder. The throttle body regulates the air supply into the engine cylinder by reducing or enlarging the cross-section of the intake port. Optionally, an electric general-purpose actuator regulates the air supply to the individual cylinders. An ignition spark ignites the air-fuel mixture within the engine cylinder. This is done via two concentric ignition coils which generate a high voltage of 30,000 volts, which is then stored briefly and then transferred to the spark plug as a high-voltage electrical charge. The engine control system Motronic enables the prioritizing and control of the numerous functions that an efficient engine management system must fill. The driver's desire for more or less torque is the key input variable affecting the electronic control. The accelerator pedal module communicates the driver's wish as a sensor signal. The engine control unit calculates the torque using data obtained as follows. The crankshaft speed sensor measures the engine speed. Further measurements come via the knock sensor, the temperature sensor, and the camshaft sensor. By coordinating all specific values, the engine control enables optimal engine efficiency along with low fuel consumption and emissions. Bosch exhaust gas treatment ensures that all international emissions regulations are adhered to. To create optimal working conditions for the catalytic converter, the exhaust gas must have the prescribed oxygen content. The broadband lambda sensor measures the oxygen content of the exhaust gas, thus providing the engine control unit with the key information needed to form the right mixture. As a control measure, a planar lambda sensor is installed behind the catalytic converter to monitor the composition of the exhaust gas. Bosch designs and manufactures a wide range of powertrain technologies for vehicles with gasoline port fuel injection. The Bosch range includes individual components as well as complete synchronized systems. Bosch provides the system technology for gasoline port fuel injection on every continent on Earth. As a system provider, Bosch possesses comprehensive system competence. This is the prerequisite for achieving the optimal integration of individual components and thus maximum system benefit. Bosch products are of premium quality. Bosch technology for gasoline port fuel injection is designed for a running performance of 240,000 kilometers. As a solid, reliable partner, Bosch maintains ongoing working relationships with automobile manufacturers worldwide, from the development of new concepts to series production to spare parts service. As an innovation driver of the automobile industry, Bosch also continues to further develop the gasoline port fuel injection system.
Bosch, invented for life.
Gasoline direct injection is an increasingly prevalent drive system for passenger cars worldwide. The growing demand for low fuel consumption and stricter emissions limits calls for innovative engine concepts. In 2020, 1/4 of all vehicles worldwide will be equipped with the gasoline direct injection system. Engines with gasoline direct injection create the air-fuel mixture right in the combustion chamber. This results in higher compression, thus improving efficiency. Torque and driving dynamics are increased, while emissions levels are reduced. In combination with turbocharging and downsizing, gasoline direct injection offers the potential of lowering fuel consumption and CO2 output by around 15%. Additional optimizations can be made with functional features such as scavenging and CVO. The Bosch offering for gasoline direct injection comprises coordinated systems technology as well as a comprehensive portfolio of individual components. To supply fuel, Bosch offers the fuel supply module with an electric fuel pump, fuel tank, and medium pressure sensor. These components provide the necessary amount of fuel from the tank right up to the injection. The fuel is compressed by the high-pressure pump to the required pressure level of up to 200 bar and stored in the fuel rail. There, a high-pressure sensor measures the current pressure. Mounted on the fuel rail are high-pressure injectors that meter the fuel and spray it under high pressure right into the combustion chamber. Bosch injectors with innovative laser-drilled spray holes provide maximal flexibility in spray configuration while minimizing wall wetting in the combustion chamber. To achieve the best possible combustion, during gasoline direct injection, the air-fuel mixture is created right inside the combustion chamber. The intake air control supplies the engine with the correct amount of air mass at every operating point. One input variable is the amount of air taken in, which is measured by the hot film air mass flow sensor. Further on, the intake manifold low-pressure sensor measures the air pressure. The throttle body controls the air supply to the engine cylinders by enlarging or reducing the diameter of the intake manifold. The air-fuel mixture requires an ignition spark to combust within the engine cylinder. For this, the ignition coils generate a high voltage of around 30,000 volts, store it briefly, then transfer it as a high-voltage current impulse to the spark plug. Turbocharging enables a larger air mass to enter the combustion chamber. Thus, more air-fuel mixture is combusted, improving performance. The exhaust gas turbocharger uses the energy of the exhaust to compress the intake air. With gasoline direct injection and exhaust gas turbocharger, engine displacement is reduced, enabling the implementation of downsizing concepts. The loss of engine performance resulting from reduced engine displacement is compensated by the turbocharging. Optimization of the individual operating points creates engines that deliver low fuel consumption and CO2 output with no loss of performance. Turbochargers require a certain minimum engine speed to attain their charge air pressure. If the speed is too low, a turbo lag occurs. Scavenging is the system innovation from Bosch that works to counteract turbo lag. To this end, the intake and exhaust valves are open simultaneously for a moment. This creates a dynamic pressure differential between the intake and exhaust sides of the engine. Fresh air flows into the combustion chamber and flushes the exhaust gas from the cylinder through the open exhaust valve towards the exhaust manifold. The increased flow of exhaust gas creates 50% more torque at low engine speeds, counteracting turbo lag. Bosch Engine Control supplies the numerous functions that an efficient engine management system must provide. The driver's wish for more or less torque is an important input variable for the electronic control. The accelerator pedal module supplies the driver's wish as a sensor signal. The crankshaft sensor registers the speed and position of the crankshaft. Additional data is provided by the knock sensor, the temperature sensor, and the camshaft sensor. Exhaust gas treatment from Bosch contributes to compliance with international emissions regulations. The planar wideband lambda sensor and the switching type sensor measure the oxygen content of the exhaust, thus providing the engine control unit with basic information for the correct mixture. Future legislation regarding particulate reduction presents new challenges for combustion engines. With the unique and innovative system solution Controlled Valve Operation, or CVO, for engines with gasoline direct injection, Bosch has successfully employed mechatronics to make a major contribution to achieving compliance with future statutory emissions limits, such as Euro 6 and SULEV. Key components of CVO are the Bosch engine control unit and the Bosch high-pressure injector. Contrary to the conventional pilot-controlled injection, the control unit and high-pressure injector operate in a closed-loop system. During the injection, the control unit measures the activation signal and determines the opening and closing of the valve needle to compute the duration of the open phase. Thus, the electronic control unit can calculate the actual injection amounts of every injection and readjust if necessary. This type of closed-loop activation makes it possible to meter even the smallest injection amounts with minimal tolerances. The precision of the gasoline injection is thus significantly improved in this area and is maintained throughout the working life of the valve, guaranteeing a stable combustion procedure. Gasoline direct injection from Bosch is a key to clean and economical engines. Fuel consumption and emissions reductions, as well as increased driving dynamics thanks to direct high-pressure fuel injection into the combustion chamber. In collaboration with automobile manufacturers on developing gasoline direct injection, Bosch contributes a comprehensive portfolio and many years of know-how. With over 50 million injectors and more than 10 million high-pressure pumps, we are now celebrating 2 impressive production anniversaries. Our system's competence enables us to achieve optimal networking of the individual components and thus maximal system benefits. As an innovation driver and technology leader, we continuously further develop gasoline direct injection. Our technological advancements, such as the system innovation, controlled valve operation, and laser-drilled spray holes, penetrate the market with mass production-ready products. Our components and systems for gasoline direct injection are designed for a high performance of up to 240,000 kilometers, a guarantee for quality and reliability. Unique in the automotive supply industry, we are present globally, close to our customers, with experts in the production, research and development of gasoline direct injection systems. From the development of new concepts to supplying spare parts, we foster long-term partnerships with our customers throughout the entire life cycle of their vehicles with gasoline direct injection.
Bosch, invented for life.